Hello everyone. In this video, we will be discussing a derivation, that is torque required to lower the load. So for that, we should have a diagram. I have taken a single thread which is inclined to a correct 180-degree line. This is my origin and this is the thread. The angle which is formed with respect to this origin, that is a reference line to the thread angle, is nothing but the helix angle line, and assume that there is a load which is kept on this particular thread. Correctly speaking, the load is kept on the top of the screw only, but since we are deriving for one particular thread, assuming this load is kept on one particular thread. And here my concept is I will be applying the torque to lower the load. So if you are not applying the torque, if the load is lowering, means we call that as so some effort should be applied. Some effort should be always applied to lower the load. If effort is not applied, what happens if the load is automatically falling down? Means we call that condition as overhauling. It means we know that we are using a square threaded screw for this screw jack application. Since the thread it extremely go under wear and tear and other kind of frictional problems, easily the head part will get removed very early. If that is the condition, means the grip will not be there. So automatically what happens? The load will fall down without applying any effort. But we have deriving this derivation assuming that the threads are in very good condition and some effort we are applying. We'll see how to do that. Just see this particular sketch. As I told you, this load is kept on this particular screw, where I'll be lowering this particular head low weight towards the downward direction. You can able to see for that I'll be applying some effort. That effort only I'll be calling it as P. In the x direction only I'll be applying it. Means like horizontal direction I'll be applying. And this P, since it is lowering, it is in the minus x direction. In case the same thing, the effort if I'm applying for raising up, means I need to apply the same force in the positive x direction. This is the first information difference you should be knowing. And second thing is the frictional force. If the load is lifted upwards, means in the opposite direction the frictional resistance will be there. Similarly, when the load is lowering to the downward direction, means then the frictional force will be the opposite to the load which is moving downwards. That is in the positive x direction it will be there. In case of the raising, means in the negative x direction F is equal to mu Rn will be there, but in case of the lowering, means in the positive x direction F is equal to mu Rn will be there. And as usual there will be a weight of the body that is always towards the positive, that is towards the gravity y direction will be there. And the normal reaction, that is always perpendicular to the axis of the horizontal axis of the load, either we are lifting up or lowering up. So for a lower and effort P is applied on the nut, and for one complete revolution of nut, screw will move axially. The forces acting on the thread profile is shown in the sketch itself. So resolving the forces along the plane of the thread profile, as we need to resolve all the vertical forces and horizontal forces. Here you can able to see this. Correctly speaking, this force is there, no? This P. This P is applied in the correct direction, but we need to resolve this P into this axis of the load. So the axis, since this P is inclined on this x-axis, this supposed to be P cos alpha and this supposed to be P sin alpha. Similarly, here you can able to see this W is there. No, again this W also we need to incline towards the x and y axis of the load. So since it is inclined towards the y axis, so it is supposed to be W cos alpha and it is supposed to be W sin alpha. Now we will list down what are the positive what are the x axis forces and what are the y axis forces. See this x axis forces, we have F is equal to mu Rn, W sin alpha and P cos alpha. All these are the x axis forces. And what are the y axis forces we have? Y axis forces we have Rn and we have W cos alpha. And even we have P sin alpha. You can able to see P sin alpha, Rn, W cos alpha. All these are the y axis forces. First let me resolve the forces which is for the x axis. So you can able to see this mu Rn which is the positive x direction. So it is plus mu Rn, and W sin alpha and P cos alpha both are in the minus x direction. So it is minus P cos alpha minus W sin alpha. So keeping all the positive terms on one side and negative taking all these negative signs to the other side. So what I will get, mu Rn equal to plus P cos alpha plus W sin alpha I will be getting. Let me consider this as equation 1. Then moving to the next one, resolving the vertical forces. Vertical forces, as I told you, Rn I have, P sin alpha I have, W cos alpha I have. Here you can able to see Rn in the plus y direction. So it is plus Rn, and similarly P sin alpha, it is also in the plus direction. So it is plus P sin alpha, and W cos alpha in the minus y direction. So it is minus W cos alpha, which is equal to 0. Again, same rule, keep Rn in one side and taking other like the remaining things to the other side. So we will be getting W cos alpha minus C sin alpha, P sin alpha. Let me write this as equation 2. Now let me substitute equation 2 in equation 1. So P cos alpha plus W sin alpha minus mu Rn is nothing but W cos alpha minus P sin alpha. So in the next step, I will be taking this mu inside this W cos alpha minus P sin alpha. So what I will get, P cos alpha plus W sin alpha is equal to mu W cos alpha minus mu P sin alpha I will be getting. Now taking keeping the P terms on one side and W sides on other side. So I will be taking a P to the left side and W to the right side. So P cos alpha plus mu P sin alpha, which is equal to mu W cos alpha minus W sin alpha. So P of cos alpha plus mu sin alpha is equal to W of mu cos alpha minus sin alpha. So I need only the P. So they take this to the other side. So W into mu cos alpha minus sin alpha divided by cos alpha plus mu sin alpha. So we know that what is mu? Coefficient of friction, which is nothing but tan phi, friction angle, not helix angle, friction angle, which is nothing but sin phi divided by cos phi. And so P will be equal to W into sin phi by cos phi into cos alpha minus sin alpha divided by cos alpha plus sin phi by cos phi into sin alpha. Now I will be taking this inside, so I will be getting sin phi into cos alpha minus taking LCM, minus sin alpha into cos phi divided by cos phi. In the denominator, cos alpha into cos phi plus sin phi into sin alpha by cos phi is there. Cos phi get cancelled, so this is only left out. This is sin A cos B minus sin A cos B is there. So sin of A minus B. Similar of cos of A minus B. This trigonometrical relations I will be using, and finally I will be getting it as P is equal to W into tan of phi minus alpha. Or if you want means you can go with A minus B, but you should be knowing A is nothing but friction angle, B is nothing but helix angle, or phi is nothing but friction angle, and alpha is nothing but the helix angle. So this is the torque required to overcome the friction between the screw and the nut. T1 is equal to P into dm by 2, and this can be again substituted here. So W into tan phi minus alpha into dm by 2. When the load is taken by a thrust collar, the load should not rotate with screw. Then the torque required to overcome the friction at the collar is, we have two conditions, that is uniform pressure and uniform wear. The uniform pressure condition is T2 is equal to 2 by 3 into mu1 into W into R1 cube minus R2 cube divided by R1 square minus R2 square. For uniform wear, T2 is equal to mu1 into W into R. So therefore T2 can be written as mu1 into W into this R is nothing but average of R1 plus R2 by 2. So this is the average. So the total torque required to raise the load supposed to be capital T is equal to T1 plus T2. You can able to see even for the torque required to raise the load also same equation we got, except this particular change where we will get tan of phi plus alpha will get, but here we will getting tan of phi minus alpha. This is the only difference between torque required to raise the load and torque required to lower the load. Thank you.